All right. So we're talking about analyzing and comparing key features of functions. So everything we deal with is going to be a function. It's going to pass the vertical line test and all that. And this one says end behavior. So there's not really enough space to graph this entire thing, but we could say, hey, if I'm going to graph this, this is a linear function. It has a positive slope. It doesn't even have to be perfect. Just making it look like this is good enough. So like we talked about when we were correcting, if you're going to do left end behavior, we're checking the behavior on the function as we go toward negative infinity. So as we go toward negative infinity, that's telling us where we're looking at the behavior of the function. And then we want to know what happens to the function values. Well, the function values continue going down, so that's going to be an end behavior of negative infinity. And when we go to the right end, so this is going to be the limit as x approaches positive infinity. So as x gets bigger and bigger, we're talking about the right end of the x-axis. The function values continue getting bigger and bigger and bigger. So that would be positive infinity. And if we take a look at this one, again, doesn't have to be perfect. Here's the most important thing. So I'm going to ask Dane. Dane, if I were to graph this, the shape of this graph has a name. Do you remember what it is? It's a parabola. Caleb, does it open up like this or does it open down? Like this, down, right? Okay, that negative right there. Now, whether it moves left or right or up or down a little bit doesn't really matter. This happens to move it left and then down, so it would look something like this. Having that general picture, that really quick drawing, we don't even need to have any points, lets us figure out what the end behavior would be. So on the left end and on the right end, this function is actually going down. So if that function is just continuing to go down as we go to the left and down as we go to the right, the end behavior on both of those would be negative infinity. Any questions there? Okay. So we have covered enough of this stuff that we know a lot about functions. We know how to analyze them. We were talking about increasing, decreasing, positive, negative, all sorts of stuff. We've got some pretty good skills. Now we want to put it to the test on kind of a real world situation. Now this is contrived, this is made up, okay? But you can kind of see where things like this might be helpful. So it says, who's the winner? Use mathematical reasoning to support your conclusion. So here's the deal. Mr. Nye's physics class used their skills to build rockets for a competition to see whose rocket could go the highest. There were 3 groups who launched rockets, and they were allowed to choose how they would present their data to the judges. Here's how each group presented their data. So you're going to be the judge of this. So we're going to look at these 3 groups. This is how they presented their information. And we're going to take that and we're going to figure out who won. So group A, our rocket's path is represented by this function. Notice it says h of t. Pretty common thing. We've got everything in terms of t over here on this side of the function, and it says t is time in seconds, h is the height in feet. So there's a lot of information there they presented to us, and they said our rocket went the highest. Next group, they illustrate it with this graph. So it looks like this, time in seconds down here, height in feet over here. So at least they're both measuring them the same way with the same units. That's going to be helpful. And they said our rocket went the highest. And then the last group, they just said, hey, our rocket's path is recorded in this data. Ours went the highest. So let's take a look at this right here. What would you do to figure this out? Mason.
I would graph it and see which one is the maximum if I wanted to do a graphing.
Okay, so if we look at this one right here, they did do a graph for us. They didn't do a graph for us down here, but we can put this into our calculator. So grab your calculator. And we're going to type that in. So I already did a reset on mine, and I'm going to type in negative 16. Okay, we're in function mode, so we've got to use x for the variable. So this is going to be x squared plus 176, x in place of the t, and then we're going to put a plus 3. And again, always a good idea to hop down there. We've got some exponents. We've got it kind of spread across the entire screen. Hop down on the next line. Make sure, is that exactly what we want? Okay, and I'm just going to hit graph. Would everybody go ahead and hit graph? Do you see what I see? Which is nothing. Okay, now, little trick. If you graph something, and let's say we have no clue what it looks like. Now, I'm hoping by looking at this function, you have a sense of maybe what shape this would be and maybe which way it would open. But if you don't have any idea, hit the trace button. And lo and behold, there is actually a point right there. It's at 0, 3. Now, I can hit the over arrow if I want, but these are really ugly numbers, and you'll notice that it's already up to 108. So if I'm going from 0 to 10 right here on the positive side, if I type in a 5, I'm going to get a big number like that. That gives me some sense of how big the window needs to be. So what we're going to do is we're going to come back here and we're going to hit the window. And this is a skill that you need to be good at. A lot of times this is trial and error. I have to take some guesses sometimes. So here's what we're going to do. Remember, they said T is the time in seconds. It doesn't make any sense, and we replaced time with X. It doesn't make any sense for us to use negative time. So let's change this to 0. I don't know, maybe the rocket's in the air for 10 seconds. Okay, the other ones, it was in the air for about 10 seconds. So we'll make that assumption right here. The X scale is totally fine. I'm going to leave this at negative 10. You'll see why, and we might want to adjust that in a minute when we see. But we already found a value of 487 or something like that. So we've got to go pretty high. So what do you want to take a guess? Keely? 600 sounds great. Now, the good part about taking a guess is the calculator, we can hit a button, it'll graph it really quick. And if we need to take another guess, totally fine. We'll just make it regraph this. A lot of times it's better to guess a little bit high than too low, because then we can kind of scale down a little bit. 600 sounds pretty good. I probably would have guessed 1,000 and just see what happens. Let's go ahead and hit graph. That's perfect. Looks great. No problem at all. What are we after, crew? We're after the max. We're going to make the calculator do the heavy lifting on this, so we're going to hit second trace. We want to find the maximum. Left bound, hey, that looks pretty good. It's a little bit to the left of the top here, so I'm going to go ahead and hit enter. And then I notice I'm at 5, so I'm just going to jump to 7 for a right bound. That way I don't have to arrow over. If I've got a sense of where it is, I can quickly type in what the left and right bounds are. And then if you want to take a guess, you're welcome to. See, that's getting pretty high there. 487. Okay. So if we come over here, if we're judges, we say, hey, we appreciate the fact that you gave us an equation, because I could do a whole bunch of stuff with that equation, and we could figure out that the max is at 5.5, 487. Somebody tell us what that means. It's a number on the screen. It's a number on the paper right now. What does it mean? It means something in the real world. This has a context. Lizzie, what does it mean?
It was at the highest peak at 487 at 5.5 seconds.
487 feet at 5.5 seconds. So if you just add some labels there, the labels give it some context. That's enough for us to say, okay, we can move on. We know what we need to know about this particular group. Next one. They kind of did us some favors. What's good and bad about what they did? Luke, what do you think?
I like it because it gives me some very clear knowledge about how much time and how high it went.
Okay.
But I don't like it because it doesn't tell me whether or not one of these numbers is the max.
Okay. All right. I like that. That's good. Yeah. I mean, there's some good information here. I mean, a picture is worth 1,000 words, but it doesn't really give us the information that we need. Yeah.
It doesn't show you how to plug it in and get the exact number.
Yeah. Okay. It's nice they gave us a picture, but if I had to take a guess, I would guess maybe about right there, just a little bit past 5 seconds. And I would say maybe just a little bit less than 450-ish. Yeah, so this is marked in it's scaled every 100, but it's marked every 50. So that would be 450. So we're going to take a guess, maybe 5.2 seconds and maybe 450 feet. Again, seconds here. They did label their axes, so we're in good shape there. So there's some good and bad stuff about that. It's nice to just have a picture. Which one do you like so far as the presentation? Mason?
I'm liking the graph, or not the graph, the equation, because we can firmly check whether it's true or not.
We can check for sure. It's nice they gave us a picture, but I would really wonder, hey, exactly how high did it go? Now, between the two of them, who's going to win, A or B? A's going to win, no question about it. If it had been close, what if that was 452 rather than 487? We would want some more information from Team B, wouldn't we? Okay, so let's come down here and take a look at this one. What do we like and not like about this? Because, I mean, we can learn something about how we're going to present some information in the future by looking at the three of these. What do you think, Wilson?
Something I don't like is it doesn't give us every interval.
Yeah. 2 seconds? You just measured every 2 seconds? That's, I mean, great. You gave us some data, but yeah.
Gives you exact numbers.
Gives us exact numbers. So that's kind of a good thing. We don't have to go hunting for numbers. Yeah.
But could one of the numbers be higher, like in between those intervals? So 381 may not be the max.
Yeah. So take a look here. Clearly going up and then clearly going down. So would everybody agree that the maximum height of this rocket occurred somewhere in between 4 and 6? Do we know exactly where it is? We don't. Now, if you had to take a guess, if it was going up at 4 seconds and it was 381 feet off the ground, and at 6 seconds it was going down and it was 377, did it go a lot higher than 380 or just a tiny bit higher than 380? Okay, take a look. At 4 seconds, it's here. At 6 seconds, it's here. It's got 2 seconds to do this. Okay? It probably went quite a bit higher. Big problem with this. We really don't know. So maybe a guess, 5 seconds. And what would you say? How many feet? Keely? 420. 420 feet. Good enough. Go ahead, snicker. You're going to snicker, aren't you? Okay?
It's required.
That's what I heard. Okay. All right. Who wins? Group A, no doubt about it. Okay. Group A, no doubt about it. Okay. Who wins for presentation? Now, I hear that Mr. Steele says presentation counts, and I totally agree with him. Who wins on presentation? Zach?
Team A.
You think Team A?
Either A or B, because A is better for getting a deeper understanding, but B is easier for someone who just wants to look at it and say, all right, this team wins really fast.
Mm-hmm. Okay. At first glance, so if we just said, hey, who gave a better presentation, it would probably look like B or C gave a better presentation. But as far as the information a judge needs, these guys probably did the best job because they gave you all the information because it's contained in an equation. And that's one of the cool things about functions and algebra in general. It can represent all the specifics really quickly and really compactly. Okay, everybody good with that?
How do you even find that out?
What's that?
How did they even find that out?
So you can learn that in a physics class. You'll also learn. You'll probably talk about it a little bit in 3 honors, definitely in calculus. Okay. So the cool thing is, from what I remember, from what I know, because somebody taught it to me, I can look at this and I can tell you why that's a 16. It has to do with gravity. I can tell you that this rocket was launched upward at a speed of 176 feet per second, and they launched it from a height of 3 feet off the ground. Oh, you should see the look on his face right now. Okay. All right. If you were going to do this presentation in the future, what would you do? Think for a second. If you were in this competition, what would you do, Lizzie?
If I were to do it, I would have the equation, but also have the graph next.
There you go. If you did a combination of these, if you drew a picture of this, had this, and you had the function, there'd be no doubt. Yeah. What would you do? That. Okay. All right. Excellent. Very good. This is a record. You have 18 minutes left.
Holy crap.
Hooray!
You don't have that both.